Hello everyone, I am Alkim Avsar, a PhD student in Systems Engineering in Stevens Institute of Technology. My advisor is Professor Paul Grogan, and today I'm going to present you our paper. Companies adopt a teamwork approach to complete tasks faster and more effectively. Although teamwork offers a wide variety of advantages, potential failures cause unexpected negative outcomes. Team interactions found as one of the key factors affecting team performance. The main motivation of this work is to identify factors affecting designer behaviors and interactions in engineering systems to increase efficiencies. Previous studies in engineering design literature show personality traits are one of the key factors affecting team interactions during design activities. This study investigates locus of control personality trait, which affects how people perceive the world on two extremes as internal and external locus of control. Individuals with external locus of control believe their life is guided by fate, luck, or other external circumstances that they cannot control. In contrast, people with internal locus of control believe their decisions and efforts are guiding their life. Previous research in other settings indicates locus of control affect team performance but does not provide insights specific to engineering design. Understanding effects of this trait in engineering design tasks can provide better understanding of how individuals with different views of control interact with each other and with the design system. This study fills a literature gap to understand the effects of locus of control personality trait on team performance in cooperative engineering design settings. Our research question is, how does locus of control personality trait affect team performance in cooperative engineering design tasks? To answer our research question, we have three hypotheses which are shown as three different paths in our logic model. First hypothesis investigates how our controlled input variable locus of control affects the output. Second hypothesis investigates how locus of control input variable affects the designer behaviors during the design activity. And our last hypothesis investigates the effects of different designer behaviors on outcomes. We had 35 volunteers for our experiment who completed a 24-item locus of control inventory. Based on questionnaire results, we selected 24 participants and created three different team combinations as internal internals, internal externals, and external externals. In our design tasks, starting from initial zero input vector, designers' objective is to choose input variable x to achieve target output vector y. Designers were able to make an action by clicks, and with each click they were able to travel certain distance on the output slider. Their goal was to finish tasks as fast as possible. The inputs of the designers in the same team affects each other's outputs, and pairs were only able to share verbal information. In this slide, you are seeing our first regression model, which investigates the relationship between logarithmic transformation of completion times with number of variables, task order, and team combinations. Analyses indicate there is statistically significant difference between completion time of different teams. As also seen in the box plot, II teams finish tasks fastest, whereas IE teams show the slowest performance. The second regression model investigates the selected designer behavior of clicks per distance, which indicates how much distance designers traveled by each click. Results show statistically significant difference of designer behaviors. II pairs were following the strategy of traveling shortened distances by each click, whereas IE teams use more clicks to travel certain distance. Our last regression model shows the selected designer behavior of clicks per distance has a significant impact on completion times of teams. Results show statistically significant difference between performance outcomes of different team combinations. Internal teams had the best performance and internal-external teams had the worst performance outcomes. There can be possible explanations for these results. II teams' higher motivation due to their personality might help them to show higher performance outcomes. On the other hand, when an internal and external pair together, internals' high motivation and eagerness might negatively impact externals, since externals tend to believe they do not have the control over the outcomes. Also, internals may also perceive greater stress when paired with externals because they might feel their teammate is not motivated as themselves. Qualitative researcher observations during the study suggest designers with similar locus of control personality trait tend to create better harmony, but we do not have quantitative information. Analysis results show statistically significant difference in designer behaviors based on locus of control. II teams follow a strategy of using more clicks to travel a certain distance, meaning taking smaller steps towards the outcome. In contrast, IE teams use the least number of clicks per distance, meaning taking larger steps. Results show II pair strategy was more effective, helping them to have higher performance outcomes. On the other hand, IE teams had more ineffective or unnecessary action outcomes to reach completion. This may be due to several factors as stress level, lack of communication, and understanding between team members. Understanding the main causes of designer behavior differences between diverse teams and similar teams can help better support all types of engineering design teams. Results from this study are subject to several limitations. First, the sample population does not include both extremes of locus of control personality trait. And second, participants were paired solely based on the assigned internal or external label. And consistency and reliability of responses for the questionnaire were dependent on the subjects. And finally, the experiment uses a highly simplified design task that is representative of cooperative design only at an abstract level. In future, we want to have more realistic tasks. And the ultimate aim of this research is to identify certain recipes to increase the performance in teams without excluding certain characteristics or group, but rather designing engineering systems that support all types of teams and individuals. Thank you so much for listening.